Hey everybody, welcome back to another edition in geometry. It's Mr. Anderson here. We're in section 10.3 today, and we're talking about arcs and chords. Okay, so again, we're dealing with circles, and we're going to specifically talk about arcs and chords today. All right, let's get started. Objectives. We're going to recognize and use relationships between arcs and chords, and recognize and use relationships between arcs, easy for you to say, arcs, chords, and diameters. All right, so first thing that we need to talk about today is this. In the same circle, or if you have congruent circles, remember congruent circles have the same radius and the same diameter, so if it's in the same one or in two circles that are exactly the same, the minor arcs are congruent if their corresponding chords are congruent. So in this situation here, remember the chord is the line from F to G, and the arc is around the outside of the circle from F to G. That's the arc. So basically what this is saying is if you're told that FG, that chord, is congruent to that chord, if those two are the same, then you know that the arc FG has to be the same as JH as well. And that can work vice versa also. If you know that the arc FG is congruent to the arc of JH, then the two chords also have to be congruent. So it can go either way. All right, so let's take a look at a quick example. In this example, it tells you that RS is congruent to TV. And so it says the measure of RS, the degrees here, it's 85 degrees out here. It says find TV, so that's this one over here. Well, you say, well, if RS, the chord, is congruent to TV, the chord, then the arc RS is 85, then the arc TV has to be 85. So the measure of the arc TV would be 85. Okay, pretty easy, right? Yeah. Whoa, two of them, look at that. Okay, so here, now this is where, like I was saying before, we have two circles that are congruent. So it says circle A is congruent to circle B, which means that they have the exact same size, and of course they're the same shape. They're both circular. And so the same thing holds true here. It doesn't have to be in the same circle, but two circles that are congruent, the same thing will happen. In this case, it says that the arc WX, this one here, it's marked as being congruent as the same as arc YZ over here. So we know these two arcs are the same, then that chord YZ has to be congruent to the chord WX. And so in this case, we just make 7x minus 2 equal to 5x plus 6. And then we use some algebra to solve that. So minus 5x plus 2. So we've got 2x equals 8. Divide by 2. X is 4. Yay! Oh, but wait. We weren't trying to find x, were we? We were trying to find WX. Okay, so say, oh, well, that's this right here. So just plug it in. So WX would just equal 7 times 4 minus 2. 7 times 4 is 28. Minus 2 would be 26. And by the way, if you wanted to check yourself, since these two chords are supposed to be the same, you could put 4 in over here as well. 4 times 5 is 20, plus 6 is, 26. It's the same thing. So you can kind of check yourself there. All right, the other thing here that's going to happen is, now this is a little bit trickier. In a circle, if you have a diameter or a radius, so in other words, if you have a line that's going through the center here, and it's perpendicular to a chord. So here, this is the chord XY, and I've got a line that's going through the center, whether it's the diameter or the radius, and it makes a 90-degree angle here. It will bisect both the chord and the arc. So bisect, remember, means split it exactly in half. And so, and then the reverse of that's true. If this chord is split in half or this arc is split in half, then this must be a diameter or a radius, okay? So keep that in mind. It's going to split those in half. Let's look at a few examples. All right, circle G, measure of DEF is 150. So here DEF is this whole entire arc here is 150 degrees. And we've got this situation that we were just talking about. Here is a chord, DF, and then there is a radius that goes from E to G, and it makes a 90-degree angle. And so we'll say, oh, well, this is our situation we're talking about. So this radius will bisect not only the chord, but the arc. So in this case, the first thing is it says, if DEF is 150, find DE. Well, where's DE? DE is right here. Oh, well, that's just going to be half of DEF. So the measure of DE is just going to equal 75. And again, that's just because of the rule that we were just talking about. It just cuts that in half. Well, the other thing is, let's find DF. Well, where's DF? DF is from here to here. Oh, that's the entire length of the chord. Well, what they told us here was they said from D to H is 5. So we said, oh, well, this must be, if that's 5, then that means it had to have gotten split in half. So that means this side would have to be 5 as well. And DF would be the total of that. 5 plus 5 is 10. So in this case, DF would equal 10. Okay, so same kind of thing for both of those. Okay, now it starts getting a little more fun. As a matter of fact, this might be our last. No, we got one more after this. This is probably of the things in this section. This is probably the most difficult one. And they've thrown, to make it even more difficult, they've thrown a few extra lines and stuff in here that even make it harder. But we've got kind of the same setup that we were just talking about. We've got a diameter that it makes a 90-degree angle with this chord. And so therefore we know, oh, it's going to split, RT is going to split exactly in half. And the chord and also the arc RT will be split exactly in half by that. Okay, so keep that in mind, but we're going to have to go a little bit different here in how we approach it. So let's walk through it. All right, first of all, QS is 14 inches long. QS is the whole diameter. All right, so that's great to know, but what's even more important, and you'll see in a second, is what's the radius? Okay, well, if the diameter is 14, the radius is 7. So what I'm going to do here is I'm just going to, that's the radius, basically the radius there. I didn't quite get all the way to the center. But this is a radius. From Q to V is 7 inches. That's the radius. Okay, we got chord RT is 10. So this whole chord is 10. Well, what we just talked about was this radius, or the diameter here, will split that chord into 2 equal parts, right? So if RT is 10, that means this part here would have to be 5, and this part would have to be 5, right? Okay. What else do we know? Well, that's all we know. What are we going to try to find? VU. We're going to try to find from V to U. Okay. Well, that's interesting. We don't have any real rules for that. We know from V to S would be 7, but we don't know anything about from V to U. We know it's going to be less than 7. That's the one thing that we do know, right? All right, here's how we're going to approach that. Okay, we're going to be a little tricky. This is really tricky and kind of fun. Okay, check this out. All right, I'm going to draw an extra line in here from V to T. Okay, so I'm going to draw a line from V to T. Now, if I draw a line from V to T, what do we call that line? We could call it a radius, right? It's from the center to the outside part of the circle. And we just found out, this is why the radius is important. Now, remember, Q to V was 7. So we know that V to T is also 7. All radii are congruent. Okay, so we know the length of that is 7. We know from U to T is 5 because that got split in half. What we're trying to find is from V to U. Okay, and so if you look, we're making a little triangle here. And so we're just going to call this, let's make sure there's not an X in there, we're going to call this X. So we've got a little triangle that's 5 on one side, 7 on one side, X on one side. And you think, what do I know about triangles? Guess what? Since this is a 90-degree angle here, and it's a triangle, it's a right triangle. And what do we know we can do in a right triangle? The Pythagorean theorem. Oh, yes. Okay, remember the Pythagorean theorem? A squared plus b squared equals c squared. You just have to remember which one is c, and if you remember, the 90-degree angle here is at u. Straight across from that, that is the c. Okay, so 7 is your c, so that means x and 5 are a and b. X squared plus 5 squared equals 7 squared. We're going to solve that and then find out what x is. So x squared plus 25 equals 49 minus 25. So it looks like we have x squared equals 24. How do we undo the square? We take the square root. And so in this case then, I didn't know that happened. That's interesting. Okay. What I'm trying to do is, hey, there it goes. All right, if you've been watching some of the recent issues here, I've been having some calculator things. Okay, so then to find the square root of 24, we just go second function. Where is that square root? I think it's there. It's in this light blue color. It's hard for me to see. 24. And so that looks like that's going to be, we'll call that 4.9. We'll round it to one place there and call it 4.9. Hey, I got two calculators. So 4.9 inches. Does that seem like that makes sense? I mean, if you look at 4.9 inches, does that seem like this should be about 4.9 inches? If from V to S is 7, well, it's a little bit less. That makes sense. If you go by the way it looks here, this side was 5, and this was 4.9. It looks like they're about the same length, so that seems like that's probably correct. So it doesn't hurt to just kind of look at your drawing and your work and see if it should make sense. If we would have gotten an answer here that was like, 8.2 or something, and you said, well, wait a minute, that doesn't seem like that should be right, because from V to S should be 7, so it should be less than that. So always kind of think logically and go, hey, does this seem like this should make sense? And in this case, it seems like yes, that should be good. Okay, the last thing then that we need to talk about today is chords that are equidistant from the center. Okay, so once again, if it's in the same circle or if it's in two circles that are congruent, the chords are congruent if they're equidistant from the center. Okay, so equidistant means the same distance. So if you look at these two chords, JH and FG, they are congruent if the distance from L to the chord at a 90-degree angle is the same as the distance from L to this chord at a 90-degree angle. Okay, if those two are the same, like let's say if this was 2 and that was 2, well, then we would know, oh, well, FG has to be congruent to JH. Okay, so let's look at an example. In this situation, here we go, we have a circle from the center to the chord at a 90-degree angle, from the center to the chord at a 90-degree angle. They're both 3 units away, and so we know, oh, well, EF has to be congruent to GH. And we're told here EF is 3x minus 6, GH is x plus 8. So we say, oh, all I have to do to solve this is set them equal to each other. 3x minus 6 equals x plus 8. And then, of course, we do a little algebra. Minus x plus 6. So now I have 2x equals 14 divided by 2. And it looks like x is 7. Yay! But wait, it said find EF. Oh, okay. So that's not my answer. I got to go back and plug it in. And so EF would be 3x minus 6. So I'm just going to plug this in. 3 times 7 minus 6. So this would be 3 times 7 is 21 minus 6 is 15. And by the way, if you want to double check yourself, shouldn't GH be the same exact thing? If I plug 7 in there, 7 plus 8 is 15. That's good, okay? All right, last one. Now in this situation, what we're given is the length of these two line segments here. We're told that they're 90 degrees and they go straight to the center, but we don't know for sure if these are equal to each other or not, do we? But look at what they've told us. They said EF, that chord EF, and GH are congruent. They're both 24. So if we know, so this is just kind of the opposite side of what we just did. If we knew that these two are congruent in here, then we know that the chords are congruent. Well, if the chords are congruent, then the two little line segments here from the chord to the center also have to be congruent. So once again, all we have to do is just make these equal to each other. So 4x minus 3 would equal 2x plus 3. Algebra, so minus 2x, and then plus 3. And so it looks like here we have 2x equals 6 and divide by 2. And so it looks like we have x is 3. But once again, oh, hold on, that's not our answer. We were trying to find PQ. So PQ is this distance right here, so that means plug it in. PQ is 4 times 3 minus 3. 12 minus 3, which is 9. And by the way, how could we check that? Hey, the other thing should be the same distance, right? Let's try that. What if we plug in 3 here? 2 times 3 is 6. 6 plus 3 is 9. That's good. Okay, great. Well, that's all for today. Appreciate you being here in section 10.3. This is Mr. Anderson saying until next time, hasta la vista, baby.